Right, your final exam is scheduled in this way. Many of you already know how the online exam or Blackboard-based exam is managed. Okay, I give you 3 time slots, one each day, starting from Thursday. So Thursday, Friday, and Saturday. By taking Evan's complaint last night. So I shifted one day.
So that's the best time. 7 p.m. till 10. If we don't finish it good, 10 p.m. we go out, drink, to forget the test.
Is it going to be your last?
No, I'm just saying, like, if we don't do it in the class.
This is not the last meeting that we have, right? Oh, by the way, in your final exam, there is no class. Okay? So, but week after your final exam, we'll have a presentation meeting here. Alright? So I'm going to explain that a little later. So final exam is scheduled for these 3 days. So I'm working for 3 days, but you guys pick one of those time frame and complete your work. Only one sitting is allowed, which means you cannot come in and go out. You can go out, but never come back. It's only one time login. Okay?
And even if we start, for example, let's say 9 p.m. I start the test, I still gonna have to.
You have only 1 hour then.
Oh, really?
Correct. Yeah. You should be there.
That's my birthday weekend.
Really? Oh, before it wasn't like that.
What about before?
Other class that I took, for example, it was 3 hours.
That's all the other class, okay?
Yeah, but it's the same school.
You need 3 hours from when you
Right.
started.
I do not know. It is kick you out. It kicks you out. But last semester, some of the students said, "Oh, they kicked me out." Yeah, earlier days, Blackboard do not kick you out, and it marked the time elapsed in red, so you can see, oh, I have overtime. But if you can do, you could do, okay? But do not take a risk. So if you want to take, then you need to start 7 p.m. Any problem from you here? Okay. For example, anybody wants to do Sunday 5 o'clock in the morning? No. Right? This is good, right? 7 to 10. Okay. Another thing that you need to do before the end of this semester is a group project.
I have a question. Thursday morning, happens in class.
Correct. So if you, as usual, come to this class so that you can take the exam wherever you are. You can take that exam here if you want.
All classes going on?
Huh?
We don't have classes there's no class that day?
Where were you? I saw you while I was announcing. Okay. Group projects. I know you are involved in a group. So that you need to work together and complete. You make one completion. Okay? But for the submission, each member should submit the same material. Only because otherwise I have to grade yours manually by opening one submission and then go the other way to grade yours. It takes a lot of time, but if you submit yours, then I can grade it directly there. Then your number grading can be in your grade book. Otherwise, I need to insert the number into each individual grade book, which takes a lot and may cause some mistake, because I have to do that manually. So to avoid that, I wanted to submit from each person. It's perfectly fine, the same complete work, because of course you work together.
So you want the whole project from every single person?
Yeah. There's a written report, and the presentation is needed. You can come here in person to make presentation. I'm going to be here the last Thursday before Christmas, right? But you need to be here by 6:15. For example, why I said 6:15 is because some groups may not come, which is not encouraging, but still technically possible. Some group make a presentation and record it and post it on any media server. One typical media server is YouTube, and as far as you give to me the URL, okay, address. So with that address, if I can view your presentation successfully, then it will be fine. Okay? Another thing is, it's not allowed, for example, part of your team members come here, part of your team member post their presentation on YouTube. Then that is not a single presentation. I want to make a single presentation. So if you want to, any one of you cannot come here physically, then one suggestion is you record it. You need to gather together and record your presentation one by one. So each one should do the presentation of what you achieve, okay? Only the portion that you achieve. So all together in one video clip, and post it YouTube and give me URL. Before you give me URL, you need to make sure that that URL is reachable where there is rendable videos. A couple of times in my life here, that presentation, some students URL, but there's nothing. What is the consequence? I mean, 0 points for that, because I cannot grade, right? So make sure that URL is there, and I'm sure as far as once you submit your video clips to YouTube, it stays there forever, but in reasonable time period. So you do not have to worry about uptime of that server. So YouTube, there's all like hundreds of professionals are watching and running YouTube servers 24/7 on behalf of you. So we will be happy.
Is it possible for you to allow us all to have access for MDMA?
What is it?
MDMA?
Oh, that's, I think, who is handling? Yeah, always possible, but I'm not handling it.
Right. So did you know about that? Jen?
He did that, but now I think it is done by, no. It's a math professor. Yeah, Dr. Paulino? Yeah, Paulino, yeah. John Paul, I call him John Paul. Dr. Paulino, his office is just right. Yeah, the first office next to Dr. Chen's.
So just write an email
in the management group?
Yeah. Other question? Mechanical question? So tonight and next week we'll have 10 nights. And then 2 weeks from today you will have a final exam. So no class. And then week after that, there's a presentation. By the way, if you want to make presentation, then you need to come here in this classroom by 6:15. Do not come here 8:30, okay? I'm not going to wait for nothing until 8:30. But as far as we have a presentation back to back, then definitely I'm here. So start from 6:15. The first team and next team, whatever the time right after first presentation, and so on and so forth.
Four teams. How many teams do we have? 4? So by 8:30 anyway, it's going to be finished. If all the teams come here.
No, what I'm saying is no one show up.
I understand.
And the first team comes 8:30, then
Not many teams.
yeah.
I understand.
Any other mechanical question?
So the final is going to be multiple choice, you said, right?
Look at that.
No, seriously, we thought.
Edmund, when you go for interview, would they give you multiple choice?
No, I'm asking you because.
Try not to, but maybe.
If they give you multiple choice, chances are it's bad signs.
Multiple choice, then it isn't easy for me to. I mean, for Blackboard, it automatically graded, so it is good for me. But I don't think another thing is that if you fail, you fail, right? It's a true or false type question. If you miss, you miss completely. But short answer type of question, always partial, right? Is there anything that I give you 0? Probably so. If you put there some songs and some drawings. Has nothing to do with this class.
Are you going to have some form of review or something in the aspects of, what the finals are going to be on?
Finals is very similar to the homework. Yeah, homeworks. Yeah,
Right.
all
Even the
homework.
Even the homeworks.
Other than homeworks, not many questions. Yeah,
Not many.
Homeworks,
How many questions
right.
are going to be in the total? The finals?
I do not know, but not more than 10. Then somebody never forget to ask, will there be bigger question and smaller question? Then I would say yes. So maybe 5 big question. Each big question has multiple smaller questions. As I explained in another class, those keep this in mind. If I ask like big question, for example, I didn't give you homework assignments from that. The last encryption, right? A5-1, right? A5/1. Remember that we have a register, 3 registers, and each can be each register is representing polynomials, and then there is a clock bits and some of the bits that you need to take into consideration of exclusive ORs. Those are all the work that we done the last class. Okay, but I didn't give you homework assignments. But that will be asked also. So in that case, I may ask you, which register is first considered? Number one. Number two, what is the feedback bits computed from register 1? What is the first key computed from A5/1 algorithms? All such things. Those are the steps of the computing and generating streaming keys for your smartphone, right? So it's not really many small questions, but I want you to think those are the steps of the questions that can lead to the final answer. I could ask, for example, oh, what is the key final answer? Then it's like all or nothing type of question. You may correct it or you may fail it. So to avoid that, number one. Number two, to help you to reach the final answer, I give you some steps. So if there are multiple small questions, please think in a way that they are all related in that sequence. That is the way that you need to solve to give the final answer. Okay? Any other?
Any programming questions?
Did we do many programmings? No.
So no Python?
Yeah, we did.
505, okay? Come back tomorrow.
We did programming.
But I didn't ask you to, hey, you should know this. No.
So no programming, no Python.
No Python, but C++.
No, seriously, like, yes or
No,
no?
no.
Oh, okay.
Just
So
Ruby.
all we're gonna do is find the keys and these stuff. And
whatever,
like we have the homework.
whatever you do,
in the homework.
the homework assignments and some of the quick computation and simple concept, for example. I'm not going to ask you write an algorithm of something. It doesn't mean much.
Did the encryption Python as well?
Right.
RS4.
We did.
That's not going to be under
No, I'm not going to ask you Python, but algorithm.
Okay.
You said you weren't going to do it out.
Yeah, for example, RC4. That what you did, right? Then I ask you step by step in certain order. So if you follow that, then you can get the final answer. Okay, set to go. This. All right, tech nights. So we will have 2 tech nights. So one more nights on Arduino NRF 24L L24. It's not 1. It's L. Okay. So you will know what it means. Okay. So we'll use a microcontroller. I know some of you asked Raspberry Pi or BeagleBones, Droid, for example. There are many microcontrollers available, but the one that we are going to use in this class is the very simple microcontroller, which is called the Arduino Uno. Okay. Some other controllers, microcontrollers, are functioning a lot better, a lot powerful. That they are almost like your computer. So it's nothing but a Linux box. You could say so, but not Arduino Uno. Okay. So what is a microcontroller? As appears on the slide, it is just a small computer. Arduino Uno has also operating systems running inside, but one thing uniquely and significantly well-designed format of coding is available in Arduino Uno, which is similar to, well, you will see the Arduino Uno, okay? So what is the format of the coding? So simply, there is a setup module and then a loop module. So once you set up a computing environment, okay, and then there is a loop, that loop is running continually. In typical programming, when you learn Java, Python, C, C++, then instructors never forget to warn you that your program should terminate. Please make sure that your program should be complete at some point. Unless otherwise, it runs forever. If your program uses a lot of computer resources, then your computer resources is fully occupied, and therefore finally your system will stop, no response, right? Not all endless loops stops your computer, but if a program uses a lot of resources. Resource means memory, storage, CPU also, little bit. All right. Where are the microcontrollers used? Many places. Car. Last weekend, I went to the city and I parked on the street my car. I have a small car, but it's a hybrid. Parked. I believe that because my car is a hybrid, I do not have to worry about the battery. But on that night, when I turned the ignition, so all the lights on, but no engine. So it was first time. The car is about 6 years old car. Never happened to that. So I assume that one big battery, therefore it has always sufficient power. But the fact that I learned, still there are two batteries. Oh, you know that?
Yeah.
One battery, that is the battery usually all the cars have, and the other big battery that is using for moving force. So big battery is still okay. The small battery is gone. So when I turn on, engine never move, but all the lights on. So it's so beautiful, but all the warning signs. If you have only one battery, then completely dark, right? But that is the case of a hybrid. So I was, is it it's going to be total? But anyway, it's about 6 o'clock. Very dark in the city, Sunday evening. Oh, there's no, how can I? So I called my insurance company, and fortunately I have emergency road service premium there. So lady arranged some near towing car and some other companies, and towing car came. We wait don't ask me how long I waited. Finally, Toyota came and he tried to tow my car. So I asked him, hey, can you try before you tow my car? And then he tried and he says, oh, engine probably, because he knows. So hybrid. So maybe battery issue. And he brought out a small battery and jumped it, and it worked. So what am I saying now? Okay, here's the points. Microcontroller. So I moved my car, and still some warning signs. One of the critical warning sign is brake warning, no brake. Oh my God, I already started. It's a brake, it's no brake. So the stop sign, I slowly, and I try to make a side brake. I do not hear any click. Usually when I pull up, then it's clicking, right? Click, click. So wow, why the brake is a problem? Maybe this is the problem. So I moved. And then a couple of other blocks. When I see, immediately all the warning signs disappeared. And when I tried this, clicked. So what happens?
You recharge.
No, you know what?
So everything is, there are some sensors. Those are sensors sensing that, because there's no battery, so it says no no brake, no nothing. So all sensors reported that, not because there's no such components, but because no power to that sensor. So each sensor reports to my dashboard. So I was really scared because no nothing there, a lot of warning signs. But within 2-3 minutes, all disappeared. When I checked a little bit, so everything became normal. Point here is that each component, there is a sensor monitoring each small components and then reporting if there is something wrong. Okay.
So why did the battery drain though? Do you need a new
I do not know.
battery?
I do not know.
That's a mystery. Was it cold?
There's a mystery.
No, but he says,
Sunday was not really
he said
cold.
since 6
Yeah.
years. You have this
Another
since 6
thing,
years, right?
another thing is this. My son came from college. He has a very bad driving habit. He never turn off. When he parked, he leave on. But cars eventually turn off, right? That may be the reason.
Probably just need to recharge the whole system.
Yeah. So, cars has a lot of microcontroller. So each one has microcontroller that has sensor monitoring the components and reporting to the dashboard. Okay. So car has powerful computer, phone of course, toothbrush.
What type of microcontroller is just for speed?
Who, the toothbrush? No, you know, but you ones that they have a satisfaction
A lot.
thing.
Thing is this. The electric toothbrush. We had two toothbrushes. I bought one, cost about $30. That's normal, right? But for my wife, I want to take care of my wife better. So I purchased, I think, $150 toothbrush.
Wow.
Would it be nice? It looks nice. Functioning well. It has a lot of problems because of that monitoring, all the issues. It has a lot of sensors in it.
Up to you. You don't have to like put it towards your mouth. It goes by itself, right?
By itself and microwave oven,
Yeah.
of course, right? Copier machine. Oh, copier machine is nothing but computer.
Yeah, definitely.
So
Sensors,
what happens?
Check.
Can you hack copier machine
Yes.
to reset all counter to 0.
So
If you can do, so that our department may save budget.
Trying to break into that thing.
Remember the last year, the spring semester, right? Somebody used the copier machine, and the copier company, machine company, charged to the departments, I think, $25,000. Copy, $25,000. So in
Because
the copy.
charge is per page.
So it was I think April. So that remember that we have cyber skill competition teams. So we try to order lunch every Saturday. They're supposed to have that, but all of a sudden they freeze all the budgets. No money left. Therefore, we cannot. We had only one time provisioning from the department. All others we did by ourselves. Television,
Smart TVs.
PC keyboard. Some keyboards, each keyboard it has some light sense. Therefore, it knows which key is pressed. Appliances all. So, the more fancy and sophisticated and intelligent devices has more sensors. Which means, I'm not talking about sensor, but computer, microcontroller.
What is the sensor microcontroller?
They're not the same. Microcontroller is like a computing the data collected by the sensor. Okay, what Arduino? The word Arduino can mean three things: physical device, hardware, or programming environment, that is also Arduino, or community and philosophy, that is also Arduino. Okay. Let me see. This recorder right now cannot. For Mac recorder, I'm recording this lecture. While recording, I can turn on and off the camera, but not this Windows version. So originally, I planned to show, but I cannot. So I can distribute to you Arduino Uno, so you work together. Yeah, I need to give. You have cable, right? Christmas. Why you work this way? Okay. Oh, is it over there? It's up to you. Yeah. Did you see that? What happened more? I'll give you more. More means this is expensive.
Professor,
You wanna buy?
that's around
I mean, like, I'll do that. Okay. So how many do? 1, 2, 3, 4, 5. Okay, you have now Arduino, Uno. Arduino is one of MCU. What is MCU? What MCU stands for? Microcontroller units. So MCUs includes Arduino, Raspberry Pi, BeagleBones, Droid. But from my investigation, there's an MCU called Droid. That is the most powerful. That is almost the powerful computer. Okay.
Also, one called that it's like portable computer, which is small. I forgot the name. It's like an actual computer. They put it out there. It's like a USB. Raspberry Pi, right?
Okay. Yeah, Raspberry Pi. Okay. So it has a digital pins, PWM. I think pulse wide modulation, pulse width modulation, pulse width modulation, or pulse wide modulation. This is kind of a modulation. So pulse modulation it sounds familiar to you, right? When you learn the encoding, there's a pulse modulation encoding. Similar to that.
Pulse width modulation.
Which one?
Pulse width modulation.
Width?
Modulation.
Yeah, width. So it's a width is a pulse width. So it has digital pins and analog pins. Digital pins is pulse width modulation pins, so that it can receive and send out data. Analog usually used for inputs, so it's 10 bits of pins for resolution. It has two voltages, 5 voltages and 3.3 voltages. Okay, and that analog voltages can be converted into 124 data points if you like. If you do program on your Arduino Uno, so that you can split, for example, any voltages, okay, into 10,024 pieces. So very subtle voltage blocks can be identified. Arduino Uno, it has 6 analog inputs. The port numbers, it has a number, A0 to A5. Megaboard has 16 analog inputs. Evan has megaboard. Evan, can you hold up your megaboard? It has so many pins available. And also it has more memory. And then nano board. Oh, not here. Williams. I do not remember his name. Williams taking 520 together. He has a small nano. Arduino Nano, right? Board. It has it is a smaller but more analog inputs. Okay, so this slide explains all the parts, hardware parts. I want you to take a look. For example, this part. That is EPROM. It is RAM, but EPROM. If you have Arduino Uno, then the size of EPROM is 256K only. That's enough to include your program. Sometimes I save data into that EPROM. If you do not want to transmit the data to some other remote systems, that is possible. Analog, we have 6 pins, and also power pins, 3.3 volt, 5 to ground, and voltage in, which means if you want to use the voltage from other devices, then you can plug into this, other than the voltage is pre-defined. And this is the power outlet, power extension, directly from your wall. Okay, so there is a small. So you can plug in here, but in our case, because you have a laptop, so you can connect the power. You can receive power through this USB line. I know you have a mini USB right now, right? So you can use it. Is it mini or macro? It's not micro, right?
Not micro. Micro is the first.
Right. What is it? What's the name of that USB?
I don't know, to be honest.
Huh? Type B USB. Okay. And then we have digital pins from 0 to 13, and another ground pins, and some other indicator. So we will use some of those for this experiment. We're not going to do anything for sensor, but we will do data transmission only. So how your data can be transmitted with your friends. Okay. So what we will do here, so how many teams? We have 5, right? So you can, your Arduino talk to their Arduino, yours also, same thing. One time you send it to there, and then at another time you can send the data to this team. And then team back, Mark and Evan, James, your team needs to talk to me. Okay? This is a little longer distance. Still okay.
Will it be okay with all the communication going out of the roadmap?
Yeah, dude. Paris.
Right. Yeah, if you want to experiment at your side, then you need to have one more Arduino more laptop and one more. So it's really no problem, right? So, all right. This is some This is a table comparing multiple different Arduino Uno. The price went down from the number that you can see on this slide. Right now, I think maybe 70% of those, right? So Arduino Uno is about $20. About $20. 15. Sometimes free.
Micro Center has $5.
$5?
I can't pay $6.
On Black Rock Friday?
I just went in, $6.
Is it 12 was?
Since not
Oh, it's just the board.
Okay. This is a chip. It's a microcontroller chip. Okay. Originally designed by Harvard University. ABR. Flash ROM, flash memory, EPROM, EEPROM. So you can, we're not going to do that here, but if you have on your own Arduino Uno, then try to, and also if you work on sensor, then collect the sensor data and save it on EEPROM, and then later you can do some computation from there. Okay, tools to use. So we're going to use the tool. You need to download from that website. There are 3 versions available: Mac OS, Windows, and Linux. Whichever you have, I want you to download. Okay. Mark, Evan, will you follow me? You need to download it.
I have a CD.
Arduino IDE. Mark, do you have an Arduino IDE? Or do you ask Evan to do that? Okay. We have so many Mac users.
So is Arduino its own language?
Huh? Oh, it's a C. C language.
C.
But very, very simple C. Don't worry about it. Oh, you're a C programmer,
Yeah, you
right?
back here, that's right.
No?
Java and Python. C is different from C++.
Same language. But C++ is object-oriented. Is that right?
Windows has an app, right? An actual app.
I'm not sure of what that app would do. Try to download the IDE.
Yeah, Arduino IDE. It's like an
The
app
IDE.
version. Yeah.
But you said app.
Yeah, like an app version. Here. Should be this one, right? Yeah. Nice.
So Arduino has IDE version of user interface, so user can develop and run and also monitor through a serial interface. And another way is that command line user interface. ABR do, there's a command line interface to your Arduino and sensors that you need to understand all command line on all the languages. Okay? It's a lot. If you know that, you can do a lot more than the way that you could do using graphical user interface, of course, right? Graphical user interface, as you do program, sometimes you think, oh, I need to do something more than buttons available or provided. Is there anything that I could do? Then you need to go back, come back and study for command line user interface, okay? Then this is really program hackers tool. Okay, this is the idea that you are going to work. You have a laptop, right? And you have a connection, adapter to your Arduino Uno. And if you have any sensor devices, then they are built over breadboard. The beauty of a breadboard is that you do not need to do much about soldering. Okay? Sometimes you have to. While I was working on this sensor network, now I'm skillful soldering. I can solder small pins. Okay, but don't try too much about soldering. Sometimes you burn your suicide. But me, I do that very carefully, and I enlarge my eyeballs.
How do you do that?
If you have some magnifier, that helps a lot, because it's very, very small. In the small space, you have to do so many other things. And then there is a IDE. This is the IDE. Okay? So you need to do some of the programs here. So I'm going to explain that another slide. But once you develop and once you load your program on Arduino Uno, then you can detach this Arduino Uno from your laptop and then supply the battery. As far as it has a battery, then it runs the way that you program from your laptop. Okay? So the program that you successfully compiled on your laptop should be loaded on that EEPROM. And if you supply the power, then that Arduino Uno runs by itself. When you plug in, there are multiple lights, built-in lights. So test LED, just right behind the USB. And then another light, power LED, that stays on all the way. That's just right next to reset button. See here, reset button? And this is the lights. This reset button is not necessarily here. Each Arduino Uno has a different place where there is a reset button. So not necessarily the position of the parts is not really standardized. Not necessarily standardized.
Different schematics.
Schematics is like coding in this paradigm. Okay, like a sketch.
It's a design. Then,
Yeah, design. Yeah. All right. The configuration. Two things that you need to configure. Okay, we'll do that all together. Okay, there's a tool menu on top, right? There's a tool menu. Then you have a serial port. This serial port needs to be selected. Some of the Windows, I believe a Mac provides the proper port numbers automatically, never fails. So Mac users may be okay, but Windows,
No, it's not automatic. You have to point to it.
if you do something else, but by default it gives you automatically. I wrote here, if you have a Mac, then you need to find out that you have that identifier of the USB in the DEV directory. Okay? Go to terminal, the Mac terminal, and change the directory to /DEV and type ls, list all the devices. Then you can see definitely the device that is mounted on your Mac OS. For Windows, some Windows systems, you do not have, this device manager may not display that USB number. Then you need to go back to device manager and get information from there. Device manager should pick USB connection first. Then your Arduino Uno use it the way the device manager
You need it from
picked it.
device manager and see if whenever you install it, see which pops up. It's not showing up.
Well, they could check for changes to hardware.
Yeah, do that scan for new hardware first, or delete the USB reinstall and see what pops up.
At worst case, in my life, some of the students earlier days has a big problem. In that case, you have to USB scanner or USB. There's some application programs available. So by running that application program, it searches through all the ports and gives you. So serial port is important. Number 2, the board that you need to choose. Okay, serial port, number 1, and board, number 2. So you need to choose the proper board. If you use Arduino Mega, then choose Arduino Mega. Otherwise, Arduino Uno. This is the sample of Arduino Uno IDE. I practiced this. See here, GPRS SIM 900. That program, but somehow device has a defect. It doesn't function properly, so that we cannot do other additional exercise. That's bad, but that's what happens. So instead, we will work on only communication through NRF, radio frequency ones. So there's 2 buttons, upper left, check button, that's for compiler, and then arrow button, that's an uploader. So once you check, and if there is no error, then in this console message box, you don't see any particular message. Particular message means some message in red color. Then definitely there is some issue. Okay, so don't upload it. It's useless. So you have to fix it until you have anything but anything but in red, which means usually in white on this black background. So finally, if you see here white whatever the message is, then presumably yours is ready to upload. This message is also for uploading issue also, right? So everything. Yeah. So using Arduino, what you need to do is that write your sketch, which means a program, and press compile button. Remember there's a check button on circle. And then press upload button, arrow. From there you could do something.
Does it need to be C?
No?
Program needs to be in C.
Easy, yeah. Are you familiar with?
Try with C++.
Similar. Okay. What we will do here is NRF 2401. Is a Nordic. Okay, Norwegian. Science, electronic sciences, or something like that. There's a company. So I'm going to distribute to you. You already have.
But it's not high enough.
Model 2 is expensive. Ours is also.
Should be.
No, that's the name.
For this transceiver, do not try to plug in now because that is sensitive. And if you no, that's okay. But power, do not plug into your Arduino Uno. Okay. If you plug it in wrong pin, then it'll burn. We lose this.
This one is disconnected.
Already gone.
Like 3 times you've got me in.
All right. This is a short description about your transceiver. Transceiver that you have right now is a 2.4 gigahertz radio transceiver. Okay, and also it is a half duplex transceiver. Hey, half duplex. Can anyone explain what half duplex?
Half duplex is a short. It takes it's a shortest path. Made of half transmission. Full duplex.
Start from singlex. So what is singlex? Simplex. Simplex.
Asynchronous.
Simplex. Simplex and duplex. Simplex, as I said, half a duplex transceiver, which is what we have, is not a simplex. Simplex means it's unidirectional. So always sender, always receiver. But ours is not simplex, which is duplex, sending and receiving. But it's not full duplex. So now, Chris will explain the difference between half duplex and the full duplex.
Half duplex is when it's only able to send and receive at separate times, not at the same time, right? Yeah. So
like if you're using a radio or something and you're transmitting, you can only transmit to them. You can't be listening at the same time.
So some of the walkie-talkies, there's a half duplex, so that you have to press button and you talk, and if you want to hear, then you release the button and let him talk, so that you can listen. That's a half duplex. Full duplex. Any example of a full duplex? Yeah, phone, voice phone. Remember that Rosario, when I talked to him, he also talked. So, hey, let me first. Okay, that's a full duplex. So what is our transceiver? Our transceiver is half duplex. What does that mean? You have to send it
One has to send
at one time. You have to send it or you have to receive. So you have two different programs to make. We're not there.
It's giving me an error.
Two. Huh?
It's giving me an error.
I didn't give you an error. Did I give you?
This is giving me an error, not you.
Which one?
Oh, okay.
Which one?
With a 10 LED? Yes?
No. I mean, when I run the when I upload the code,
Which code?
Right.
It's giving you
Right. It's not properly made. Wait. This transceiver has 256 possible channels. Some documentation says 80 some channels, but anyway, you don't have to worry about. It has a lot of channels that you can use, and this is very, very important. Address. Okay, in your program, you need to assign an address, like a MAC address. How many bytes for used for MAC address? Yeah, how many bytes to specify? 48 bits. So, no, 64. Oh, no, 6. 6 times 8 is what? 6 times 8? Oh, 48. Yeah, 48, yeah. So 40 bytes, no, 6 bytes. So we use the 6 bytes also.
64, right?
No, 6 bytes, not 8 bytes. 6 bytes. 6 bytes is the size of representing the address. That is the same as MAC address.
8 times 8.
No, MAC address is a 6 bytes.
Oh.
And then data, the size of data that you pack at once is 1 byte to 25 bytes. Okay? So today we will do only test to send and receive, but next week we'll send the data and try to encrypt. Okay? And then transmission rate is only 1 megabps, up to 1 megabps. What is BPS that we would have when we have 5G technologies available? What is the transmission rate when we have 5G available?
Above 300, right?
300 gig, right? A lot. Here is a 1 meg.
Oh, I thought it was
1 meg.
like more than 300 megabytes.
No, a lot. Right now, gig, 4G,
Because 4G is
2 gig. maybe.
300, right? 4G is 300 megabytes.
No gig. 4G is 2 gig. Okay. Nordic low cost, of course, low cost. Bidirectional, which means half duplex, 2.4 gigahertz ISM, of course ISM. 2.4 gigahertz is ISM. What ISM stands for? That's industrial, scientific, and medical. and all others I already explained. So what we will do is using NRF24L01 and Arduino Uno and do some programs. And we just skip this. Because we do not have time. Okay, here's the important thing. At home, you can check this web page out, and then pin description. If you see okay. If you, I'm not sure. Each one might have different design, but it has 8 pins. 8 pins. If there is a label, then you are lucky. If you don't have any labels printed there, then you have to be very careful. But all the configuration remains the same. So upper right corner there is ground, and left there is a VCC, there's power. You don't have to worry about. And the CE and CSN, those 2 pins are very, very important, and so on and so forth. So all that. So when you see that, it is just like this. See here. So I want you to take a look at your transceiver. There is a VCC, so power pin, and there is a ground pin, and then CSN, CE, right? So what happens here is that this ground pin, see here this is your transceiver. This is your Arduino Uno. So what happens here is that from this ground, this should be connected to the ground pin in your Arduino Uno. And also VCC pin, there's a 3.3 volt. So if you plug that pin to 5 volts, then it heat up. If it remains that longer, then burn, which means you lose that. So this one, VCC pins needs to be jumped to Arduino Uno power 3.3. And this is very, very important. CE and CSN, those 2 pins, CE pin and CSN pin. CE pin needs to be hooked up with the pin 9 and the other pin 10, okay? And all others you do not have to worry about, because they are all here, as I said, hardware pins. So these are not really needed, but these 4 pins needs to be connected properly. So I want you to take a look at it. Wait a minute. I'll take back here. As I said, in this slide, you have to continue to hook. SCK pin number 5 needs to be in pin number 13 of Arduino Uno, and MOSI in pin 11, MISO in pin 12. Okay? In your program, we do not need to touch any of these pins, but pins are needed to be connected. But pin number 9 and 10, those two pins description will be used in your software here. So these two pins are used for and managed by your programming. Okay? So keep that in mind. All others, just wiring, just jump. And then in your program, only 2 pins are used. All right, transmit packets. So you, 2 teams. You have a transceiver and an Arduino Uno connected to your laptop. So one team needs to do program for transmission. Another team needs to do for receiving. Okay? And then you can take turn. The program that you need to do, before you do programming, you have to understand those functions. Okay? Those functions can be found from that web page. Thing is this, if you are working on transmission, then you have to understand all of those functions. If you want to do receiving, then you have to understand all of this. And then you have to make 2 separate programs. And at one time, at each time, you have to run 1 program. At another time, in another program. Okay? Why? Because I said this device is half duplex. Half duplex. It takes long. Okay, so let's take a look. This is very, very important. So anyway, we have to take a look. Okay. So I'm going to discard this and bring up here. I want you to type this. Okay, so RF24 library API appears. So let's take a look. First thing that you need to know is begin. There's a function called, first thing that you need to know is constructor. RF24, this constructor takes CE pin and CS pin. Remember that CE pin and CS pin? See here, CE pin. CE pin goes to pin number 9. CS pin, in other words, CSN. CS pin goes to pin number 10. Those 2 pins are needs to be used to construct RF transceiver. Okay, this RF transfer. So if you click this, then full description of that. So RF24 takes 2 parameters, CE pin and CSN pin to construct an object of NRF 24. Okay, that needs to be done first. And then once you have an object, then you need to begin. Okay? So there's a begin function. So begin function does not take any input parameter, so it says a void. So begin, it begins operation of the chip. Okay? ABR chip. So it's a little bit of those. And then another thing is, once your objects of RF24 begins, then you need to set acknowledgement. Set acknowledgement. Auto ACK, right? Set auto ACK enables auto acknowledgement packets, which means when you set this, then packet is sent out to receiver or to the transceiver. Remember that when they need to communicate, they need to first try to set up. If it is a set, then they need to share the acknowledgement. Setting up and understanding each other is nothing but the begin function. So when you do begin, then it has to shake hands. Okay, begin to shake hands. And then acknowledgement from both sides. Once it is acknowledged, then and some other you are ready to do. So, for example, here enable acknowledgement to payload. This is nothing but payload. Instead of this acknowledgement to payload, if you send the real payload, then there is a data communication. But in this example, we do acknowledgement payload. And some other times we have to do retrial. So there is a set retrial function somewhere. Yeah, here, set retries. So it has time delay and time counts. If you click that, then it explains. Set the number and delay of retries upon failed amount. So delay is nothing but how long to wait between each entry and how many times are you going to do. For example, so maximum 15 times. So it tries 15 times to communicate. If it doesn't go through, then it stops. There is a set retry. And another thing is now open writing pipe. Here, open writing pipe. Only one pipe can be open at a time, either from transmitter to receiver, always transmitter to receiver. but you can change the pipe that you will listen to. Do not call this while actively listening. Remember that stop listening first and then change the address if you need to, right? That's for that open writing pipe. And then there is a start and stop listening somewhere. Here, start listening and stop listening. Start listening is usually the function that needs to be done at the receiver side, right? Receiver needs to listen because the transmitter sends the data to receiver, so receiver needs to listen, but sender, when transmission is done, then the sender needs to stop listening. And then print detail, write, available, and read, those all will be used. So let's move a little faster so that you do not lose your interest. Some of you already lose interest. So this is a transmitter for testing. You need to download NRF24L01, RF24H, printf-H, print.H, all the C files, and then do this program. So I'm going to explain this a little bit, and then we will practice. It's a pin CE needs to be in pin 9, and CSN needs to be on pin number 10, and we have some counter, so it counts 11 times and stop. If you increase that 110, then more transmission. Just simply like a bookkeeping of your transmissions. And done, when it comes to the full of counter reached, then you set the done to true so that your program will stop. So this is nothing but a simple bookkeeping process. And RF24, this is very important, right? Here, wireless SPI. This is a variable that you set. The type of that is RF24. RF24 that we just looked at, right? So this is a constructor. Constructor takes CE number and CSN number and to construct. So this is nothing but an object of RF24. So you create one NRF24 objects. So this is your objects. This is the object that you defined based upon RF24 description. RF24 description is the one that we looked at. Remember that here, this is a constructor. So by taking two numbers, CS pin and CSN pins. So here, yeah, C CSN. And then you need to set the address, pipe address in hexacode, in long type. But how many bytes? So you have 1, 2, 3, 4. 1, 2, 3, 4, 5. 5 in this case. That's okay. 1, 2, 3, 4, 5. So you can do 6 if you like. This is like a MAC address, okay? This is address that transmitter and receiver can communicate. So you need to have you can change this a little bit. If you copy this, then everybody shares together. Don't do it today. We'll do that next week so that you can break in others. But in this case, only pairwise. Two teams share the same address so that we need to make sure that sender's pipeline message reaches at the receiver side and vice versa. See here in this program, there are two modules, setup and loop. See here, loop, setup and loop. Back, setup. You need to first start to begin in this data rate, 56,600 bps. So you need to also pairwise. You need to set the same transmission rate. Okay. Receiver and transmitter side should have the same address and same transmitter. I mean the transmission rate. Otherwise, it may not receive properly. And then, this is a serial. This begin is in the serial class. Serial class here is SPI, serial peripheral interface. And then this is RF 24 functions. Begin and auto acknowledgement payload and retries. So it waits every 5 milliseconds. How many times? 15 times. So 5 and 15. And then you now open writing pipe. So in this case, you need to use that address. This is the address. So through that address, how many address possible in your transceiver? 65,000, right? 65,000. Stop listening. So after you do, then stop listening and print details. This is a setup. Once it is set, then you need to do endless loop. But we don't do an endless loop here. But if not done, then we continue to do this. And then finally, when we reach the count, then we say done equals true. Therefore, at this point, this looping process stops. Okay. So although Arduino by default is running endlessly, but according to the way in a way that you program, definitely you can stop, right? Like this. And then some of the messages. The one that I want to point out here is that we send so it's a counter increase every time. Here, wireless write. So we want to write counter. Okay, counter starting from 0 to 11. I believe that is what we said, right? Counter is up to 11 here. So we want to send the counter. But if you see here, ampersand, those who knows C program can understand what ampersand means. Anybody knows what ampersand? in C programs, there are two things. Pointer, which is a star, and ampersand, that's a reference. Okay? So in pictorial, in your memory, for example, in your C programs, so you have some memory space, and you change the value here, right? So this is called, this is address, right? So this space is called, say, if this is A is an address. And value itself is nothing but A, star A. That is a value. If you say ampersand A, then when I do count, then it reference to the original count back here, and say when I send, although I send this counter number, if it is changed at the other side, then I would say to my friend, hey, you use my data. I'm not going to send my data to you. Think very carefully. If you have an ampersand, then you use my data. So data is held by me. Whenever you need, you use my data. That is ampersand. If we do not have ampersand, then what happens? Hey, here's the data you have. A little different.
Where is this? Where is it in the program? Let's see.
What is your question?
Where is that in the program that we just talked about?
Here.
Because I don't see it.
Here. This ampersand. It's just ampersand count. Okay. So what happens is that I increase the count in my side, but count is used by receiver side. So we need to make sure that receiver use the count that I am using. In that way, we know that they are transmitting. So this is the receiver side. I want to work on this. And then that's a transmitter side. Receiver side, all remains the same, but here, open reading pipe. Receiver will use to read, right? Transmitter, here, writing. Open writing pipe, that's for transmit. What happens is that transmitter try to write on that receiver side. It's an open write. The receiver, I receive because I want to read the data that is received. So it is a reading pipe, and start to listening because we do not know when the data arrives at my side. So receiver needs to listen continually. And then loop is very simple. Somewhere here it reads. And then do some. So this is the next. This is something that we will do today. So let's continue to do. Otherwise, we cannot finish in 9 o'clock. So what you will do is this side. I want you to write a transmitter program, and the left side I want you to do the reader. And over there, Are you going to do read or write? No, you cannot do both. This is not full duplex.
I have both. I didn't say I'm doing both.
So you choose one. So that.
I have two boards. I do have two boards at the time to do it.
So you have some of the connection.
Oh, that's right.
So we're missing.
That's right.
Yeah.
Let me see. We have, hold on. That's the issue.
You staying here? No.
Just down there.
You'll see on
Let's get a shot.
Okay, here's what you need to do. For example, I'm going to give this to you. Give
My
me-
program is not working. Just to let you know, 2 hours ago. I know I told you it's not working. So if you can help me.
You need those jumper cables.
Okay, we'll do this a little later. I'm going to give you a demo, okay?
So I have here. Pay attention to this one. It's all coming.
Okay. So, here's what you need to do. Close this. Okay, so when you click on that Arduino IDE, this is Arduino IDE, right? What is this? This is transmit. So I'm going to do transmit Mark Evans. You will receive, okay? Hold on. So I didn't do anything. So what you need to do is to plug this and connect to your USB driver. If you have that sounds, then it's a good sign. And then what you need to do, first thing is that click on the tool, and then the board and port needs to be checked. Right now is Arduino Uno, so my board okay, and port number. What happens? Okay, port it identifies the COM port 6, and it says Arduino Uno, so perfectly well recognized in my case, so that is okay, right? And if you see your Arduino Uno, then just right behind this firmware EEPROM, there's a green light on, which is power is on, and then there is a little yellow ones that is test button. It tests well. So far, I don't think I have any problem. But there is a reset button just right next to USB. In my case, so if you click this, and then the test and come up.
Mine's
So-
not on. It's not staying
The
on.
LED stay on?
Yeah, the orange one is not staying on mine.
The orange one doesn't stay on. The orange one's
I didn't
supposed to
listen.
place. The green one's the one that's supposed to stay on.
Yeah.
So,
We have that data is ready to go to the orange like you just said.
So we'll see.
Orange one's trying
Okay, and then hold on. Let's do this first. Okay, then we will look at yours. This is a check button. This is for verify. In programming concept, it is called the compiler. So click that, and then you see here the monitor, the screen. Error compiling for board. What happens? Error compiling board. Do you know Uno? Compilers. So you need to do this. Oh, thing is this.
yeah.
You need to download these libraries. So I said here, right? What I said there is you can download it from each GitHub, or I said or from www.scysecure.org. What is that? scysecure.org.
Cyber.
This is our server. Okay, let's go to our server. I already posted that in there. So if you go to, for example, scysecure.org, then here, download for classes. I have here ISP 520. We didn't get to this yet. ISP 560. I want you to download all of this, and these all should be in the same directory of your program. Okay?
Which folder?
Any folder where your the Arduino program is located, in the same folder.
Yep.
So for example here, I do not know where
Are the
is
drivers
this.
or?
Doesn't matter. Mine is saved at Arduino. Where Arduino? 555 Arduino. This is not what I want. So let's make it a little more clear. I'm going to do
Tools or drivers or references, libraries or where?
no, where your program is located. not the Arduino IDE program, but your program.
I don't know where is my program. I don't know what.
That's what I'm looking for right now.
No, you don't plug into this, too.
Okay. So if you see, this is a little different, right? So when I compile this, you still have problem? Why?
Mine's saying access denied. For some reason, so
Mine says you would.
I don't even know how to do this.
what does it say?
Where's your, ours is on print F, not being declared.
Is the Arduino problem?
That's how logically you have to deploy
So what are we missing?
all files inside this
Sometimes, yeah. Brand new, couldn't figure out why the network card was disabling itself from the back. One of there are two audio services running on the machine. They decided to control so much that they short circuited short. Just long enough that it would completely kill the virus. And it would do that every time we started to do it.
How did you figure out that was
Where?
Because the absolute general piece, you loaded everything, you start putting in keys, by keys, by keys, by keys, and that's what took us like 2 months because of all that. And then it's not working the day after we put it in. Technology sometimes. So we had to take it out and get it back to it. I did send it back, and then I sent it back to tell me I would use it. Turns out it wasn't me. So, at least you know, like the guy who was put the chip back in there, and it out. It's the same company who made Firefly and today, and they look similar, but they're different sounds. And I was plugged it in, and it was a little disappointing.
I'm not crazy. I would never do this myself. It seemed like a good idea at the time. I would have had someone like do it when you were now, we gave it a further joke. I want to try soon to be Absolutely. Yeah, but I agree. It's like this was cut from the side and then
Just tell me you're at least 25.
So I learned that this one I played with I learned that I go down I didn't lose function in my hand for I learned there were some little like I learned there were lots of things in this again
That's great. So he can pay by punching the machine.
So I put my hand on the door, come on. The door down, you put your keys out, I put my hand and I put my hand on the door down.
Yeah, but that also makes you a really terrible burglar. You're gonna go in, just like you gotta like break into a place, you're gonna go to the door, it's like
I'm not sure what happens this. I need to figure that out. Instead, let's do the simple ones. If you click File, then there are a lot of examples. So click on example. Bring one basic one, and analog reading, and which ones that we want to? This probably needs some. Let's do the analog read serial. It doesn't bring in. Why?
They had the same issue. You doing this more? We want to try it out.
How do you do it?
We're doing no works, but we can't connect the receiver because we got wired.
Oh, this? Yeah, use this.
Thank you.
I don't know why. I think Arduino device is some problem. Arduino device problem? Let me reset and doesn't do. Oh, he came here. Oh, yeah. So, thing is this: if you choose any example there, then it'll come up another IDE. So I have two IDEs. One that is for analog read serial. The other one bare minimum. Oh, this is nothing, right? So, for example, let's try to compile to see if it works. So my case, board and ports good, so I can compile. Because it has nothing, it should compile.
Nope.
Still loading.
Yeah, it's compiled successfully, and if you click this load button, upload, then it'll be perfectly well. If you do not have a red or other amber color, then it is okay. So I'm going to remove this. I don't need that actually. Let's try another and make sure that I have a board and port number properly set and compile. This has a little more than the other. Yeah, compilation looks good, and upload. Okay, what happens is that if you compile and upload, then here your Arduino Uno will have totally the newest ones loaded. Okay, so when you upload, then it overrides. So right now that is on my board. See what happens. Here sensor, serial prints, so that we may be able to see some of the analog read from the port A. In order to see that, then you need to go back to the tools. There is a serial monitor. If you click that monitor button, then this is the signals that is currently received from A0. Right now, I didn't put any A2 button A0, right? So some of the signals is read from this A0. That's what happens. A0 means analog pin number 0. So I wanted to try and get familiar with the compiling and uploading, not our complicated program, but a simple program examples available from your Arduino Uno IDE. Okay, so try. I think so. While you are trying, I'm going to figure out what happens with.
What's going on there?
Well, this is simply, see here, if you see this program, it says it's set up serial communication, which means this is SPI, serial peripheral interface. And in loop, this guy wants to read some data from the pin number A0. Pin number A0, there's nothing right now. So any garbage is now read, and that is printed here. Serial port here. So that is printed right now.
So it's just miscellaneous.
Right, miscellaneous. But anyway, in this way, you will know that your Arduino Uno runs. See here, because of that, you have another light, which means data is now transmitted. So I wanted to verify your Arduino Uno at least runs with a simple example before we get to the complicated. Let's see yours. Please don't now.
So did you do? Third line is for it's sending.
This compiles.
Oh, you run
This one, yeah, but the other one is
it's transmitting or it's receiving.
1,000.
So right now you're
That's
transmitting. Well, it's a dual, it's a half duplex, so it's only one cycle at a time. That was like you just send it out, that has to be the range is power in this one is to state that it's ready. Sorry, for your range.
I think that I. Yes.
He wants us to download the profile, which helps in the development of these processes. It's like a question. Then once we have the script, we roll out what characters or something to send. The script is saying
And then go to the message.
Oh,
your monitor. See if you see something through the
What it means is that whatever the number is. Oh, I know why.
I saw like nothing but black.
Hold on.
Mine. You have to check this 9600. Whatever baud rate that you have here, when you receive, when you want to see through your monitor, you have to check. This should be the same baud rate, 9600. Then you have that number. Okay.
So what is it doing now, for example? What did we...
Do a little more complicated one.
But
We're trying
we're still trying to send something, right?
No.
Doing that complicated one. I want you to do small example.
Because I want to handle something.
This is probably the one that I.
I might have some. I might.
80. Whatever.
So, somebody asked.
All the members. He wants to use Oh, you want to do it? I don't have to. So then it's easy. Just download it. Download it from the Windows side, the original.
Errors, right?
Put it on the CD. If you don't have the thing, I can put. You go to the program, give me you don't have CD? I have CDs. That's what I'm saying. Because mine didn't have
We got the transmission line on. There's a receiving and a transmission. Receiving and
No, well, you run the same program that I'm running over. No, I'm not running I'm just running a program from here, basic program, example program.
oh yeah.
Objective C, right?
No, this is not. Just see. Yeah.
There's Objective C and C are different.
Right.
So when you see, C sharp, C++, C++, Objective C,
Yeah.
C.
Oh yeah.
Why do they all call everything C?
Yeah, in general they are C. So once you know one language, then you can understand the others.
Will you be here tomorrow after 5:05? I need extra help.
A little bit, yeah. I'll stay a little bit. Sure.
Fridays are not your office days? Fridays are not your office days?
I do till what 1:30 or yeah.
I have a. You ever use Nessus? You know Nessus? I'll show you tomorrow. I have a Python.
Do not expect something that I can help you if it's not course related.
No, it's a Python script.
Right. I may be of your help. I'm interested in the Python that you can bring from somewhere. I am really interested in, but do not expect that you can have a solution from me. So we work together.
I don't want to.
In your Arduino IDE, if you have some of the files here, if it is not, if you have an error, then there are two ways that you can do. In your code, sometimes you have less than sign and greater sign. Using these to include header file or within double quote in some situation. So there are two different ways that you can do. I'm going to explain this next week, but those who really need to follow this, which means if you click sketch, then there is included library. And hold on, all the way up, your manage library. No, here, add the zip files. If you download it and the zip file is available, then you can click this and include that zip file, whatever the zip file there, and it'll appear here somewhere, like in our case RF24. Then this will be completely and successfully compiled, as you can see. Right? Or if there is anything, for example, like this, alright, and that should appear here. You have to include the file, a header file, from wherever you have. For example, like this, if you click this, then that will appear in another file, in another tab like this. Then it'll also work. In our case, we simply use this. Okay. Right. I'll do this for the next lecture.